Have you ever imagined that beneath our feet, within this blue planet, there lies a dark realm completely isolated from the world? There is no warmth from the sun, no familiar mountains or rivers, only endless darkness and suffocating pressure. This is the deep sea, a domain filled with bizarre creatures and unsolved mysteries. Among all the deep sea mysteries, the Mariana Trench is undoubtedly the most enigmatic. Black pearl. It is not only the deepest place on Earth, but also the ultimate frontier of human exploration. What kind of survival wisdom do those creatures, who tenaciously live in such extreme environments, truly possess? How do they create miracles of life amid darkness and crushing pressure? Let us dive into this profound blue abyss to uncover the truth and lift the veil on the most hidden corners of our planet. The deep sea is one of the most extreme environments on Earth, and the Mariana Trench is the ultimate extreme among them. Its deepest point, the Challenger Deep, reaches a depth of 10,948 meters, over 2,000 meters lower than Mount Everest, the world's highest peak, at 848 meters. Here, there is no light all year round. Temperatures hover between 1 and 4 degrees Celsius, and the water pressure is 100 times greater than at sea level, enough to crush a tank into scrap metal in an instant. Yet, astonishingly, this place, considered the ultimate death zone, has given rise to countless breathtaking forms of life. In the darkness of the deep sea, there exist creatures that can only be described as monsters. The glass squid, for example, has a body as transparent as crystal and a bizarrely shaped head, making it look like a ghost from an alien world. The anglerfish, with a glowing lantern on its head and a devilish appearance, is enough to send chills down the spine of the faint-hearted. There are also purple-red sea cucumbers, gliding freely through the darkness, resembling alien creatures straight out of a science fiction movie. These creatures are not only bizarre in appearance, but each has evolved its own unique survival strategies, thriving in the resource-scarce depths of the ocean. Take the transparent squid as an example. Its see-through body not only serves as perfect camouflage, but it can also use bioluminescence to attract prey or confuse predators. As for the anglerfish, its lantern is actually a trap made up of luminous bacteria, specifically designed to lure in small fish and crustaceans. The reddish-purple sea cucumber, on the other hand, feeds on organic debris on the ocean floor, playing the role of a scavenger in the deep-sea ecosystem. The survival strategies of these creatures showcase the extraordinary craftsmanship of natural selection. Even more astonishing is that the ecosystem of the Mariana Trench is far richer than we ever imagined. Near hydrothermal vents at a depth of about 2,000 meters, scientists have discovered densely clustered giant tube worms and leisurely crustaceans. These hydrothermal vents emit scalding plumes of thick smoke, creating an extremely harsh environment where water temperatures can reach several hundred degrees Celsius and the acidity is extremely high. Yet, this place is a paradise for life. The giant tube worms rely on symbiotic bacteria within their bodies to convert hydrogen sulfide into energy, completely overturning our understanding of the sources of life's energy. Meanwhile, crustaceans such as deep-sea crabs and shrimp forage for detritus on the ocean floor, becoming a crucial link in the ecosystem. These tenacious forms of life make one wonder. In the deepest parts of the Mariana Trench, in those corners yet untouched by humans, could there be even more unknown creatures hidden away? How do they manage to survive in such extreme environments? Perhaps the answers lie concealed within the crevices and mud of the trench, waiting for humanity's journey of exploration. Earth is a dynamic planet, pieced together by tectonic plates. The slow movement of these plates tears deep fissures into the crust's surface, and these fissures form trenches in the ocean. Ocean trenches are the deepest geological structures on Earth, resembling trenches of war scattered across the corners of the oceans. So far, scientists have discovered around 30 ocean trenches worldwide, with the Pacific Ocean hosting 14 out of the 17 major ones, making it the true stronghold of ocean trenches. The Mariana Trench is the most famous trench in the Pacific Ocean. Located in the western Pacific, it forms a crescent shape southeast of the Philippines, stretching about 550 kilometers in length and approximately 69 kilometers in width. It is named after the Mariana Islands, which are only 200 kilometers away. The name originates from Queen Mariana of Spain in the 17th century, who sponsored the establishment of missionary groups on the islands. The islanders named both the islands and the trench in her honor. The formation of the Mariana Trench is the result of the collision between the Pacific Plate and the Philippine Plate, where the Pacific Plate subducts beneath the Philippine Plate, creating this deep fissure. The deepest part of the trench, the Challenger Deep, is the deepest point in the ocean ever detected by humans. Its depth dwarfs Mount Everest, making it the ultimate abyss of the Earth. For a long time, this place was considered a forbidden zone for life. But scientific advances have repeatedly shattered this assumption. The unique topography of the trench makes it a natural deep well, capable of capturing organic matter that sinks from the ocean surface. This organic matter provides a valuable energy source for deep-sea organisms, turning the trench into a natural laboratory for studying the limits of life on Earth. Human exploration of the Mariana Trench began in the 19th century, marked by the brilliance of adventure and ingenuity. In 1875, the British exploration vessel HMS Challenger first detected the existence of the trench using weighted rope, recording a depth of 184 meters. This exploration marked the beginning of humanity's deep-sea exploration and laid the foundation for naming the trench. In 1889, the refitted American ship USS Nero pushed the detected depth further to 636 meters. This was close to the deepest point measured by modern standards. As we entered the 20th century, rapid technological advancements brought new vitality to deep-sea exploration. In 1951, British scientist Thomas Gaskell led the Challenger 2 survey ship, using advanced echo-sounding technology to measure the trench at a depth of 10,900 meters, setting a new record. To commemorate this achievement, the deepest point was named the Challenger Deep. The application of echo-sounding technology not only improved measurement accuracy, but also greatly saved time and manpower. On January 23, 1960, human deep-sea exploration reached a historic moment when the Swiss-designed bathyscaphe Trieste, carrying oceanographers Don Walsh and Jacques Piccard, spent 5 hours descending to a depth of 10,916 meters, becoming the first humans to reach the Challenger Deep. This submersible used iron shot as ballast and gasoline for buoyancy. Its ingenious design was truly an engineering marvel. At the seafloor, Walsh and Piccard witnessed astonishing sights: a 30-centimeter-long flatfish, giant shrimp, and a clear seabed covered with diatomaceous ooze. This remarkable feat marked a milestone in human deep-sea exploration. The Trieste is still on display at the U.S. Navy Museum in Washington, serving as a witness to history. Entering the 21st century, deep-sea exploration entered a new phase. In 2012, renowned director James Cameron piloted the single-person submersible deep-sea Challenger down to the Challenger Deep, capturing invaluable footage. Explorer Victor Vescovo went even further, diving into the abyss 4 times and setting a world record. As of 2025, there have been a total of 22 manned descents and 7 unmanned descents worldwide, with each one unveiling more of the trench's mysteries. Modern deep-sea exploration relies on advanced technology such as remotely operated vehicles, ROVs, high-definition cameras, and deep-sea traps. These devices are capable of operating in extreme environments, capturing images never seen before. For example, Japanese scientists once sent a lander equipped with a high-definition camera down to a depth of 80 meters, recording precious footage of biological activity. These technological advancements have allowed us to catch a glimpse of the true face of the abyss. In 2011, scientists discovered a giant single-celled organism, Xenothea fowleri amoeba, at a depth of 10,641 meters in the Serena Deep of the Mariana Trench. Its diameter exceeds 10 centimeters and can reach up to 20 centimeters, making it the largest known single-celled organism on Earth. These giant amoebas are not only astonishing, but they can also absorb heavy metals such as lead and mercury in the deep sea, demonstrating remarkable environmental adaptability. Professor Lisa Levin from the Scripps Institution of Oceanography stated that giant amoebas are key species in deep-sea ecosystems, but their survival mechanisms in high-pressure, low-temperature environments remain a mystery. The discovery of giant amoebas has overturned people's understanding of single-celled organisms. Traditionally, single-celled organisms have been considered tiny and simple, but these giants are able to play important roles in the 10,000-meter deep abyss. Research shows that by absorbing heavy metals from the environment and storing them within their bodies, they may serve as important purifiers in deep-sea ecosystems. However, due to the difficulty of obtaining deep-sea samples, research on giant amoebas is still at an early stage. Another breakthrough came from Japanese scientists. In 2014, they captured the Mariana snailfish, scientific name Pseudoliparus swirei, at a depth of over 80 meters. A deep-sea fish that resembles a tadpole. This fish feeds on amphipods and contains a high concentration of trimethylamine oxide, TMO, in its body, a substance that protects cellular proteins from damage caused by high pressure. CT scans have revealed that the snailfish possesses 2 sets of sharp teeth, with hundreds of teeth densely packed in its mouth and throat, allowing it to firmly grasp its prey and showcasing the formidable side of deep-sea creatures. Amphipods are equally astonishing, as they are able to survive under the extreme pressure at depths of 10,000 meters. Their shells are made of calcium carbonate, yet they do not dissolve under high pressure. In 2019, Japanese scientists discovered that the shells of these animals are coated with a layer of aluminum hydroxide gel, which effectively protects the calcium. This gel is formed by extracting aluminum ions from seabed sediments, demonstrating the unique adaptability of deep-sea organisms. These isopods feed on seabed detritus and serve as the cleaners of the deep-sea ecosystem. Some species can even secrete enzymes to digest wood, directly using wood debris that falls from the surface as food. The survival of deep-sea organisms depends on special sources of energy. Near hydrothermal vents more than 20 meters deep, the way giant tube worms survive overturns conventional understanding. These tube worms have a digestive system when they are young, but as adults, their digestive system completely degenerates, and they rely on symbiotic bacteria within their bodies to survive. These bacteria use chemosynthesis to oxidize hydrogen sulfide released from hydrothermal vents into energy, and then convert carbon dioxide and water into organic matter. The red gills of the tube worms are rich in hemoglobin, allowing them to efficiently transport hydrogen sulfide and oxygen, forming a perfect symbiotic relationship with the bacteria. Similar phenomena have also been found at a depth of 500–700 meters in the Mariana Trench, where landscapes resembling karst topography exist, inhabited by deep-sea tube worms and white clams. Chemical substances seeping from the seafloor, such as methane and hydrogen sulfide, provide nutrients for these organisms, enabling them to thrive and reproduce in such barren environments. Scientists speculate that these chemicals may originate from geological activity beneath the seafloor, injecting energy into the deep-sea ecosystem. Studies of the sediments in the Challenger Deep have provided further clues. Scientists have found that the microorganisms here have an extremely high rate of oxygen consumption, indicating that a large amount of organic matter from the sea surface accumulates at the bottom of the trench. The unique topography of the Mariana Trench makes it like a deep well, capable of capturing and accumulating settling organic particles. This organic matter provides the material basis for the activity of microorganisms, which may be the foundation of the deep-sea ecosystem. The extraordinary abilities of certain microorganisms are truly astonishing. For example, sulfur bacteria, nitrifying bacteria, and iron bacteria can oxidize hydrogen sulfide, ammonia, and ferrous compounds respectively, obtaining energy and synthesizing organic matter. The presence of these bacteria suggests that there may be even more unknown chemosynthetic pathways in the deep sea, making it possible for complex organisms to survive. In 1960, Don Walsh and Jacques Piccard claimed to have seen a 30-centimeter-long flatfish and a giant shrimp in the Challenger Deep, but this claim sparked controversy. Many scientists believe that under the extreme pressure at a depth of 10,000 meters, the bones of vertebrates would be unable to withstand it. What they saw was likely a deep-sea sea cucumber, which has tentacles for foraging, and could easily be mistaken for a fish due to its appearance. However, in 2025, even in his 80s, Don Walsh still firmly believed in an interview that what he saw was indeed a fish. Was this merely a visual illusion? Or are there still unknown large vertebrates hidden in the trench? The answer remains to be revealed. Recently, remotely operated submersibles have captured even more bizarre phenomena, such as deep-sea anemones on rock walls and sea cucumbers that resemble sea spiders. These sea cucumbers feed on organic matter in the sediment, and their sensitive tentacles can sift out tiny food particles. Scientists speculate that Walsh and Piccard may have experienced visual misperceptions due to the extreme conditions and limited lighting in the deep sea. But another possibility is that there truly are undiscovered large creatures in the depths of the Mariana Trenches, just that human technology has yet to reach them. For example, during an unmanned submersible exploration in 2023, scientists discovered an unknown mollusk at a depth of 9.0 meters in the trench. Its body was semi-transparent and featured tentacle-like structures. This creature has not yet been classified, but its appearance suggests that the biodiversity of the trench far exceeds previous expectations. In the future, as detection technology advances, more mysterious creatures may come to light. Every step in deep-sea exploration relies on technological breakthroughs, from the weighted ropes of the Challenger expedition to the deep-diving Trieste, and now to modern high-definition cameras and deep-sea traps. Advances in technology have enabled humans to glimpse the secrets of the abyss. However, challenges still remain. The high pressure, extreme cold, and complete darkness of the deep sea pose tremendous tests for both equipment and personnel. For example, the hull of a deep-diving submersible must withstand the pressure of tens of thousands of tons of water, and the battery life and signal transmission of cameras are also pushed to their limits. In the future, remotely operated vehicles, ROVs, and autonomous underwater vehicles, AUVs, will become the main force in exploration. These devices are equipped with artificial intelligence, enabling them to autonomously analyze seabed data and identify biological and geological features. For example, in 2024, the Japan Agency for Marine Earth Science and Technology, JAMSTEC, developed a new type of ROV that can operate continuously for 48 hours at a depth of 10,000 meters, capturing 4K footage. In addition, advances in gene sequencing technology allow scientists to rapidly analyze microbial communities in deep-sea samples, revealing the mechanisms of ecosystem operation. However, the cost of deep-sea exploration is extremely high, making international cooperation essential. In 2025, multiple countries jointly launched the Decade of Deep Sea program, aiming to integrate global resources and accelerate the exploration of unknown areas in the deep sea. The Mariana Trench, as a key research target, will see more exploration missions. The Mariana Trench is not only at the forefront of science, but also serves as a mirror reflecting the insignificance of humanity. Here, Life challenges the laws of nature in unimaginable ways. Giant amoebas, Mariana snailfish, deep-sea tube worms, and other creatures have found ways to survive in darkness and under high pressure, demonstrating the resilience and diversity of life. Their adaptation mechanisms, such as TMAO, aluminum hydroxide gel, and chemosynthesis, have provided inspiration for biology and materials science. The complexity of deep-sea ecosystems also reminds us that Earth's web of life is far more intricate than we imagine. The symbiotic relationships near hydrothermal vents and the active cycles of microorganisms all show that life can find a way even in the harshest environments. This resilience is not only awe-inspiring, but also prompts us to reflect on our responsibility to protect the oceans. Deep-sea resources such as rare metals and biological genes are attracting commercial interest, but overexploitation could disrupt the fragile ecological balance. The Mariana Trench, the deepest place on Earth, is a masterpiece of nature and a miracle of life. From transparent squids to giant tube worms, from the Challenger Deep to the Bathyscaphe Trieste, every revelation from the deep sea deepens our understanding of the Earth. Those creatures that tenaciously survive in the darkness are not only miracles of life, but also echoes of the human spirit of exploration. With every dive and every new discovery, we are reminded of the greatness of nature and the smallness of humankind. The secrets of the Mariana Trench may never be fully revealed, but it is precisely this unknown that inspires humanity to keep moving forward, exploring that deepest blue in the universe. Let us, with awe and curiosity, continue to listen to the whispers of the abyss and pursue the ultimate mysteries of life.